Violation of conservation of energy. In an undivided electrochemical cell. Consider an electrochemical cell for electrolysis of water, in which the cathodic and the anodic compartments are not separated by a salt bridge or any kind of semi-permeable membrane. This is undivided electrochemical cell. The undivided cell is atypical for electrochemistry, but it allows for a hitherto unknown possibility to violate conservation of energy. In the beginning, there is nothing out of the usual happening in the undivided water electrolyzer. When sufficient voltage E is supplied to the cell, no other process can occur but the evolution of hydrogen and oxygen gases due to splitting of water, expressed by the half reactions, written here, for acidic medium, giving rise to current I. U is the number of elemental reacts of electrolysis per unit time, before the appearance of the process reverse to it. Now, obviously, the product I times E is the input power, P sub in, and that will exactly equal the value of the output power, P sub out. So far, there's nothing unusual, and the ratio of the output over the input power is as expected, unity. Conservation of energy is obeyed. However, as soon as the hydrogen and oxygen gases, dissolved in solution, reach the opposite electrodes, spontaneous electrochemical recombination of hydrogen and oxygen to water begins to take place. As seen, the half reactions of recombination are the same as those of electrolysis, but occur at the opposite electrodes. Most importantly, recombination is a spontaneous process and requires no spending of energy. When recombination commences, it begins to quote-unquote steal elemental reacts from the electrolysis by the amount of V, which is the number of elemental reacts of recombination, that is, the elemental reacts of the reverse process per unit time. Since the current I is kept the same, the number of elemental reacts of electrolysis per unit time obviously becomes U minus V. In other words, the part by which the number of elemental reacts of electrolysis per unit time is decreased during the proceeding of the reverse process is V over U, while the remaining part of elemental reacts of electrolysis per unit time, after the decrease, is equal to U minus V over U, which is 1 minus V over U. Obviously, then, the power P sub in being spent for electrolysis will be decreased by 1 minus V over U, which will be exactly equal to power P sub out obtained. And the conservation of energy will seemingly be obeyed. The role of the electrochemical recombination, however, goes further. Electrochemical recombination creates an internal energy source in series with the external one. Their voltages are summed up. This saves energy for the external energy source. Now the voltage necessary to drive the given constant current is only partially supplied by the external energy source. Spontaneously appeared fuel cell decreases only the externally input energy, but not the energy obtained. Spontaneously appearing fuel cell even slightly increases the energy obtained with the bound energy T delta S. Therefore, a difference will always be expected between the output and the input power, in favor of the former. Current being the same at all times, there will always be output greater than the input, that is, power out over power in will always be greater than 1. Those who would like to ruminate more over the reality of the excess energy in this case should consider that although the actual input power is diminished by the power from the internally created fuel cell, the input power spent for the electrolysis alone is 1 minus V over U in parentheses times the product of I and E. And exactly this much is the output power, which should be present in the expression for the output over input power. An impression that the output power should be decreased by the amount which has been spent previously to produce the recombining gases is countered by the fact that said amount is equivalent to a future amount of the now produced gases. The power to produce this future amount of gases which will be lost to recombination should be subtracted additionally from the already twice diminished power shown blinking. So, we may ignore these equivalent past and future power quantities. Now, let us recap. When reverse process commences, the cell voltage would be decreased by V over U times E. Therefore, the externally applied voltage would be 1 minus V over U in parentheses times E. And the input spent electric power will become output power due to electrolysis will also change. If these are the only changes due to reverse process, then input and output powers will be equal. And excess energy will be zero. That is, conservation of energy is seemingly obeyed. This symmetry, however, is broken in a natural way in the undivided cell. By the inevitable proceeding of an accompanying process, reverse to the process of electrolysis. Indeed, as mentioned, the reverse process saves part of the electric power in the amount V over U times EI. Thus, the actual voltage which will be measured will be. Therefore, we get the following for the input electric power, when a process reverse to the electrolysis takes place, and the excess energy is observed during the electrolysis of heavy or light water, partially substituted by electrochemical recombination. We can also express the result in this way. Obviously, the above has physical meaning only for V over U less or equal to 0.5. Because for V over U greater than 0.5, the quantity of the electrolysis products, hydrogen or deuterium gas, and oxygen gas, dissolved in the solution, will be insufficient to sustain the reverse process. From the expression for the external voltage E sub 1 on the cell, when the reverse process to the process of electrolysis takes place, we get the following. And, therefore, V over U can be expressed as 0.5 times delta E over E. Thus, the expression showing that the output energy is greater than the input energy becomes equivalent to an expression which only includes the initial voltage and the change which this initial voltage undergoes in the presence of the reverse process. As seen, no calorimetric measurements are necessary for the determination of the value of the observed excess energy. Calorimetric studies are only necessary in order to explore whether in a given case, besides the excess energy discussed in the present communication, also some other kind of excess energy is produced, for instance, due to cold nuclear fusion. Violation of conservation of energy, however, has taken place in the observed undivided electrochemical cell. Independent of whether or not cold nuclear fusion has taken place at all. The analysis shown is original and has never been done before. In reality, it should have been done earlier, to explain the results presented by numerous groups in the early 90s. Science, however, has its own logic and time frame, and one cannot plan when a discovery should emerge. As a conclusion, it is seen that although the proponents of excess energy in an undivided cell did not do this particular analysis, especially in the context of the so-called cold fusion movement at the beginning of the 90s, it was premature to pronounce the excess heat found in numerous studies as an experimental error and even a hoax. As seen, it is a real phenomenon of an even greater importance than what was claimed by the cold fusion movement.